This here, this is called a variable rate seeding prescription. I refer to it as more of an advanced variable rate seeding prescription. Some of you may be dabbling in variable rate seeding. What this is this is a zone map we've created that's an intersection of your EM soil with your topography. And so what we did is we took 3 different classes of EM soil, light, average, and heavy, and we took 3 classes of topography, low, level, and high. 3 times 3 gives us an intersection of 9 zones. Then we can take yield data, and if I had the software I could show you this a little clearer, but we'll take yield data, and historical yield data, and we'll go back and say, in each one of these zones, where we have different classes of soil and topography, historically, how did I yield in those zones? Where are the good spots, the high yielding spots in this field, and where are those more challenging spots, maybe the lower yielding spots in the field? And we can assign a yield potential to each. This part of the field might only be a 180 potential in corn. This part of the field might be a 260. So then what we do is we say, okay, using our same software, we can develop a variable rate seeding prescription. And we simply adjust our seed densities in each one of these zones. And then from there, once we do that, of course, the next step is the water. And that is to say, now that I've moved my seed densities to maybe my higher yielding spots in the field, how would I address that with water through our spatial management? So again, just something to give you a little food for thought of where this is going. Yield data, this one here, basically this is a yield map. Same thing, we'll process yield data. For those of you that aren't in the habit of collecting yield data from your yield monitor, very important to do so. We're moving out of simply just getting a printout on a piece of paper that shows you how your field performed, to where we can actually turn that into a GIS data layer, plug it into software, and start to really manage that field to a high degree. So what this is it's actually using yield data, historical yield data, to determine by sector, because this is how we can irrigate, where the highest, traditionally the highest yielding part of the field is, and in this case, it's right here. So if I was going to split this field in half, maybe I'm splitting my crops, corn, beans, however I want to do it, I would split it this way, because this is what's going to give us, in terms of the corn, this is going to give us the highest yield. So again, something to think about when you have these tools, what you can really do with data. This is something new we released for this year. It's called our Drought Readiness Program. Same thing, we can take yield data, we can take imagery data, but we can help define ahead of time where in a field, in this case, where are my lowest 25% yielding sectors in this field. So if I had to break this field into 75%, 25%, this traditionally has been the worst performing part of the field. So going forward, if I get into a condition where I don't have enough water to fully irrigate this field and I have to release some acres, our recommendation, depending on, of course, calculation, let's say it was 25%, I'd throw away these 25% here. And again, it's just based on historical data, information. If I had to give up 50%, I'd give it up here. Still run my VRI, but move my water to these spots in the field. Why? Because these traditionally are my best soils and my highest yielding areas. And that's how you would get the best return. So last thing I'll show you here. So working with Fontenelle Hybrids through their AquaView program, we decided to put this to the test this year. And we said, okay, let's see how this really performs. What we didn't want to do is do a side-by-side trial, which says, okay, let's look at this field compared to this field, or let's look at this year compared to a previous year. We don't think that's good science. And so what we said is, let's take a single field. Using the EM map, we're going to basically place, in this case, 8 different varieties in these strips. So here we have 8 planted in strips, and then we replicate it on the other side of the pivot. And then we put the challenge to the grower, and we say, okay, using our software, you tell us in these green areas here, in these 30-degree sectors, how you want to water this field. You want to put an inch of water on your corn? Great, we'll apply an inch. But we're going to alternate every 30 degrees, and we're going to say, in our 30-degree sectors, we're going to use data, software, and agronomy to determine based on those field variabilities I just showed, what we think the water application needs to be and where we need to either increase or decrease our applications. And then when we get our yield data back, it's real simple. We're going to take our yield data within that strip, and in the grower's legacy portion here, we're going to add up those yield values, and then in the VRI CropMetrics piece, we're going to add up those values. And we're going to do that for all 8 hybrids, and then we're going to compare the results. So, again, emphasize, same sprinkler, same amount of rainfall, same field, same hybrid, same yield monitor, didn't change the combine going through, same irrigation schedule. Sprinkler's either on or it's off. The only thing we changed is the irrigation rate or application depth. What we see here, now keep in mind this is Pleasanton, Nebraska, but what we see here, the red is the yield response from our VRI speed control. Again, this is as simple as a pivot track GPS. This is our VRI speed control, and the blue would be legacy flat rate irrigation. What's notable here, and we were pretty excited about the results we're getting, and I'll show you a few more. So we averaged about 13 bushel better using just basically GPS pivot control and our software. What I think's telling about this is if you look at all 8 hybrids, in each case, some more than others, but in each case the VRI outperformed the non-VRI water application. And this is before we even start talking about fertigation. This is just optimizing the water spatially. Same thing here. This is out of Grant, Nebraska, a little further west, a little drier area. In this case, we did 6 hybrids, side by side, replicated. Same thing, we did every 30 degrees alternating legacy irrigation against VRI speed control. And the results from here, still pretty impressive. We averaged about 12 bushel better. And again, I would emphasize every variable being the same. Each of the 6 hybrids, the VRI outperformed the non-VRI. This here, this is getting a little more advanced. But what this is we did a test where we said, okay, we're going to do VRI zone control alternating with flat rate irrigation, and we're going to look at a single hybrid and a single soil type. So this particular one, as we'll see here, this is a single hybrid in a lighter soil. We kept our flat rate application of 1 inch, again going with the traditional, I put an inch of water on my corn, and then we let the software determine what the actual application should be in this lighter soil type. Now the software increased the water application in this particular case. And the net result of that response here was 25 bushel per acre within, again, same soil type, VRI zone control versus flat rate, same hybrid. Here we did same thing. We looked at a different part of the field, zone control versus flat rate in a heavier soil type. Here we only saw a response of about 5 bushel better on the VRI. And then here, just for fun, we looked at speed control. This is a field just to the south, but we carved out a large area here, again, that would identify just one class of EM soil, heavy soil, and a single hybrid, and we said, how did the speed control, again, data, software, agronomy, perform against legacy irrigation? And in this case, we saw, again, about a 25 bushel increase. So are we pretty close here? So again, the takeaway here is what we're doing is we're saying, let's get some high-resolution data on that field, one-time collection, and let's apply the software, the GIS software, the new technology. Let's partner that with somebody local to the area that we call, what we call a VRI specialist, to help you determine what the best application of water would be using, again, that pivot track GPS or that Valley computer main panel, and then manage that irrigation maybe once a week or so to address variability and also to be able to respond to any climate scenarios such as you don't get the rainfall you anticipate and you have to move your water to another part of the field. So, so that's the program. Again, what we provide GIS data process, and we do quite a bit of, I didn't get into this, but what we call advanced data analysis. We take yield data and we use that, we process it and we use it to break down the field, identify yield potentials at different points in the field to help with variable rate seeding, variable rate water. We use the software to place the soil moisture probes. We do all the field variability analysis, so at least you have a gauge of what that field, what the opportunity is in that field. We provide you the prescriptions. So every prescription I just showed, we actually provide that to you, and we can wirelessly upload it for you right out to that pivot track controller. And then we also, through the service, provide agronomy support. And that's somebody trained to actually run our software and generate the prescriptions so you can get on with your day-to-day business. So the program costs, basically, this doesn't include the mapping and it doesn't include the sprinkler controller. Our service, you're looking right about $8 an acre per year. And then we do that on a 3-year contract. We basically say, give us 3 years to help you fully optimize that field with respect to seed and water. And we're getting, at this point, we're getting pretty good at that. So, relatively inexpensive, we think, to the potential returns you can get. And then the EM survey, that one-time mapping, you're looking at a range of about $6 an acre, one time. So, and if you want more information on this, you can either go to CropMetrics.com. This virtualagronomist.com explains a lot of what I just showed you and gets a little more detail.